So we've got another projectiles question here, but in this case it's in 2 dimensions. So we start by saying that we know that it's projected at a speed of 39.2 meters per second at an angle theta above the horizontal. We know that what will happen to that over time is the gravity has increasing effect. It's going to veer away from the straight line and it's going to come down in some form of parabola. So let's have a look at what we know. So if we look at this point here, we're going to resolve vertically, and let's have a look for Suvat. What do we know? Well, here we know that the distance is going to be 3 meters. The initial velocity, we're just looking at the vertical component of that, so it's this component here. If that's 39.2, which is the hypotenuse, the opposite is going to be 39.2 sine theta, and we don't know theta. Here we know that the velocity is 0, a is minus 9.8, and t is 3 seconds. Sorry, I'm going to get rid of that. It's not 3 meters. That's what we're going to have to find out afterwards. So there's 2 things we need to find out. The first thing is we need to find out what theta is. Once we found out what theta is, we need to find out what the distance is here. So I want to firstly ignore s, and I'm just using u, v, a, and t. And so we're going to use v equals u plus at. And I've got 0 equals 39.2 sine theta minus 9.8 times 3. Okay, bring that over to the other side gives me 29.4 over 39.2 equals sine theta, and therefore sine theta equals 3/4. Exactly as before, I don't actually want to use this now to find s. So what I'm going to do is I'm going to ignore u, and I want an equation which involves s, b, a, and t. So for part b, I want an equation which involves s, b, a, and t, and s equals vt minus half at squared. So the distance travelled is going to be 0 times 3 plus 4.9 times 3 squared. So it's going to be 4.9 times 9, which is 44.1 meters. So for part C, the first thing I want to do is find the time taken for it to hit the ground again. So I'm still in resolving vertically, and we know now that it's back at ground level, so s equals 0. U equals 39.2 times sine theta, which is 3/4, which is 29.4. V, we're not interested in. A equals minus 9.8, and t equals question mark. So I'm going to be using s equals ut plus half at squared. And that tells me that 0 equals 29.4 t minus 4.9 t squared. I can factorise 4.9 t out of that, so 0 equals 4.9 t. 4.9 goes into 29.4 6 times, so it's 6 minus t here. So there's 2 solutions, either t equals 0, which is when it launched, or t equals 6. You could have realised that because it got to the highest point at 3 seconds and it's symmetrical, it would have landed at 6, but this is a more surefire way of getting your grades. So we know that it's been travelling for 6 seconds. We're now going to resolve it horizontally. Notice there's no acceleration horizontally, so I can use here simply distance equals speed times time. Now, the horizontal component of the velocity there is going to be 39.2 cos theta. So v equals 39.2 cos theta. We know that sine theta equals 3/4. So the opposite over the hypotenuse is 3/4, so we need to find out what this is. Well, using Pythagoras, I've got square root of 4 squared minus 3 squared. 4 squared is 16, minus 9 gives me 7, so this must be root 7. So cos theta is the adjacent over the hypotenuse, which is root 7 on 4. So I'm just going to rewrite that. So V equals 39.2 times root 7 divided by 4, which is in fact 39.2 divided by 4 is 9.8 root 7. Now, the distance is going to be the speed times time. So distance equals 9.8 root 7 times by 6, which gives you an answer of 156 metres. The least speed of the particle, which it's asking you for part D, the least speed is going to be when it's at the top of its flight path. There's no vertical speed, there's no vertical velocity, there's only a horizontal velocity. So here, your horizontal velocity is going to be exactly this, 9.8 root 7, and that gives you 25.9 meters per second.